Hello guys, good morning, good afternoon, and good evening whenever and wherever you're watching this video from. So this is part 2 of our probability questions. Part 1 we answered 2018 internal, and this is part 2. So if you haven't watched part 1, please do so. So we have this question. A box contains identical buttons of different colors. There are 20 black, 12 red, and 4 white buttons in the box. 2 buttons are picked at random, one after the other, and not replaced. Okay? Not replaced in the box. What's the question? Draw a tree diagram to show all the possible outcomes. Number 2, what is the probability that both buttons are what? White. It's supposed to be both here. That both buttons are what? Are white. Okay. So remember what I told you in part 1 of probability videos, that even if they haven't asked you to come up with a tree diagram, it is very wise of you or prudent of you to come up with a tree diagram to help you answer this question correct. Now here we are asked to draw the tree diagram, so it is very easy to do that. Okay, so solutions. The first thing before we draw the tree diagram, we need to come up with a what? Total number of what buttons in the box. So we're going to add what we have been given: 20 plus 12 plus 4. This is what we've been given. So when you add 20 plus 12 plus 4, you are going to find 36. Okay, 36 as the answer. So let's use this to answer the question. So since we have three colors, different colors, then our tree diagram is going to have 3 branches. Okay, 3 branches. So it's going to be like this. Okay, so the first color is black, so we're going to write just going to write B. The second one is red, so we're going to write R. The third and last one is white. Okay, so we're going to write W. Okay, so this is the first picking. So this first picking, or this first part of our tree diagram, we're going to write these numbers the way they are. Black. How many black buttons do we have? We have 20. 20 over total number of buttons in the box, which is 36. Okay. Red, we have 12 red out of 30, total number 36 buttons. How about white? White, we have 4. Okay, 4 over 36. Okay, this is the first part of our tree diagram. The second part of our tree diagram is this. So we're going to have blue, black, red, white. Even here we're going to have what? We're going to have another branch here. So we're going to say black, red, white. Even here we're going to do the same: black, red, white. Okay, so now we're not going to assume that the button that wasn't replaced was black. Then out of 20 black buttons, we remain with what? 19. Okay, we're going to remain with the 19. So 19 over total number will reduce by 1, which will be 35. Okay, 35. But red, total number of red will just remain the same as 12 over 35. Why 35 not 36? Because of that one for red, for black ball that wasn't replaced, it's affecting the total number here. Okay, white will still maintain. The total number of white buttons will be 4, but the total number of buttons in a box will reduce by 1, so it will be 35, not 34, 35. Okay, 4 over 35. Now we come to the second branch. The second branch we're going to consider ready here, ready button. So we're going to ask yourself, if the button that wasn't replaced was red, how many ready buttons do we remain with? So we have 12, so we remain with what? 11. So it's going to be, due to space here, let me just say 11 over 35. Okay, for black will still be 20. We'll maintain 20 over 35. Okay, then white will still maintain also 4 over 35. Are we together? Okay, now the third branch here we consider what? White. If the button that wasn't replaced was white, how many white buttons do we remain with? 3 over what? 35. Okay, 3 over 35. Then red will maintain as 12 over 35. Then what's this? Black, yes, black will maintain 20 over 35. Okay, so the outcome here, or outcomes, we have black, here we have black, red, here we have black, white, here we have black, red, black. Okay, then here we have red, white, white, black, white, red, then white. So this is the tree diagram. You are done. Okay, the second question is saying, what is the probability that both buttons are white? So I'm going to direct to this one, which is WW. Okay, and we're going to say, since it's white, so this is B. Probability, we're going to say both white. Okay, this is equals to probability of WW. Okay, then we're going to pick WW here, which is here. So we're going to say 4 over 36. We're getting this one multiplied by W, this one. So getting 3 over 35. Okay, 35 here. Okay, so you can reduce, or let's just calculate, okay, everything. 4 times 3 is 12. 36 times 35, you can use a calculator. It's going to give you 1260. Okay, and then remember what I told you in part 1, okay, of this probability. I told you that you use a calculator and punch, let's say 12, okay, over this button here, over this 1260, over 1260, 12, okay, 60 is equals to, so it will reduce the answer. Okay, it's going to reduce and find the final answer for you. This is paper 2. You don't have to struggle. This is paper 2. You are using a calculator. So 1 over 105 is the answer. Okay, so if you've enjoyed part 2, let's go together to part 3 and solve another examination question under probability.